Hi everyone, this is Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video lecture, we are going to see about Barkhausen Criterion. So, Barkhausen Criterion is an important phenomenon in oscillators. In order to provide any oscillation, we need to satisfy the Barkhausen Criterion. So, let's see what is that. So the oscillator circuit is set into oscillations by a random variation caused in the base current due to noise component or a small variation in the DC supply voltage. The noise component is extremely small, random critical voltages and currents are always present in any conductor. Even when no external signal is applied to the device, the ever-present noise will cause some small signal at the output of the amplifier. When the amplifier is tuned at a particular frequency F0, then the output signal caused by the noise will be predominant at the particular frequency F0. So this is the reason for oscillations in the circuit. So let us consider the feedback factor, let us represent by small fraction beta of an output signal is fed back to the input with proper phase, then the relation is feedback signal will be amplified by the amplifier. If the amplifier has a gain of more than 1 by beta, then the output increases and thereby the feedback signal becomes larger. This process continues and the output goes on increasing. But as the signal level increases, the gain of the amplifier decreases and at particular value of output, the gain of the amplifier is reduced exactly equal to 1 by beta. Then the output voltage remains constant at the frequency F0 and this frequency is called as frequency of oscillation. Next, let's see what is the essential condition for maintaining this oscillation. So, oscillations occur under two conditions. The first condition is modulus of A beta equal to 1, where A represents magnitude of the open loop gain and beta represents a small fraction, that is feedback factor. So, the multiplication of A and beta must be equal to 1. And the second condition for oscillation is the total phase shift around the closed loop is either 0 or 360 degree. Whenever these two conditions are satisfied, the circuit will enter into oscillation condition. Next is practical considerations. So the condition modulus A beta equal to 1 gives a single and precise value of A beta and which should be set throughout the operation of oscillator circuit. But in practice, as oscillator characteristics and performance of other circuit components changes with respect to time, modulus A beta will become greater or less than unity, so that it is very difficult to maintain a constant value of 1 for the parameter modulus A beta. Hence, in all practical circuits, modulus A beta should be set greater than unity so that the amplitude of oscillation will continue to increase without limit. But such an increase in amplitude is limited by the onset of the nonlinearity of operation in the active devices associated with the amplifier, which is represented in the next figure. So this is the block diagram representing an oscillator. It consists of a basic amplifier, an amplitude limiter, and in the feedback we are having a positive feedback network. So one of the most important application of positive feedback is in oscillators. So the basic amplifier consists of the term A and feedback network consists of the parameter beta. When multiplying A and beta, we should get the unity value, that is 1. And the total phase shift around this entire circuit should be 0 degree or 360 degree in order to maintain the oscillations. Thank you.